Great. Well, welcome everybody, and thank you for joining the first carbonNEXT monthly Carbon Talks webinar series. My name is Max Niewas. I'm a manager of carbon tech delivery at Carbon Management Canada, and the title today is Success in CCUS, Building New Technology Companies. I'd like to thank our title sponsors, Scotiabank and Prairies Economic Development Canada. We can go to the next slide. Before getting into the presentation, I'd like to acknowledge with gratitude that we're all here on the traditional, ancestral, and unceded territories of the First Nations, Inuit, and Métis peoples. And I myself am in Vancouver, so I'm on the traditional and unceded territories of the Squamish, Musqueam, and Tsleil-Waututh peoples. And I encourage you to, if you're so inclined, to put in the chat where you're calling in from today and what territories you're on. So carbonNEXT is a joint venture between Carbon Management Canada, which is Canada's industrial GHG reduction hub, with a specific focus on advancing CCUS, and Foresight Canada, which is Canada's largest clean tech accelerator that has supported over 500 ventures, has raised over helped secure over 250 million in capital, has had economic impact of over $1 billion. And I'll talk more about carbonNEXT and these two organizations later on. And the agenda for today is, today we're going to spend the first half hour launching and talking about our first annual thought leadership report, and we'll have some time for Q&A. And then much more excitingly, we have a great panel organized on what it takes to launch a new successful CCUS technology venture today. And we're joined by 3 great panelists from 3 of Canada's most exciting carbon tech companies. I'll introduce the panelists once we get there, because I think not all of them are able to join at the beginning. That brings us to the top of the hour, and then we're going to have an opportunity to go into breakout rooms to have a bit more informal conversations with the panelists, get to know them, do some joint brainstorming, and just generally make some connections. And if we're good to go, I think we can jump into the report. Okay, so our first annual thought leadership report, the title is CCUS, the Case for Canada. And in this report, we explore the project strength and the enabling environment that Canada has to offer, and what it takes to attract investments for these big scale projects, and also the innovation leadership that we have, as well as strategies to address existing gaps so that we can leverage our innovation into commercial success. So a little bit of context first on the imperative to scale CCUS to meet net zero. There are different studies that show different roles to CCUS, but essentially all of them see a big increasing role, and some of them even show that if we don't significantly increase CCUS, we essentially have no chance of meeting net zero. So this is really critical. This graph is from the IEA 2050 net zero scenarios that shows CCUS scaling to around 7.5 gigatons of CO2 per year by 2050 and further beyond that. And to put that in context, that's roughly a 200-fold scaling from today's level by 2050. So just a massive undertaking, a big challenge, but also a significant and really great opportunity. It is estimated $1 trillion market opportunity for CCUS sequestration, services, and creating low carbon materials and low carbon fuels, for example. So it's a really great opportunity, and we argue that Canada is really well positioned in this space. So first on the project development side, and our strength at a glance, and we could talk at length about each one of these, but as a high level overview, we really believe that we have the key ingredients for success. We have significant project experience. We have 5 out of the 27 industrial scale projects operating globally, and we have sequestered 1 out of every 7 tons that's been sequestered globally has been put underground in Canada. So we have really great experience and expertise in this space already. Increasingly, we also have the climate and CCUS policies to make these projects a reality. Of course, we have the national price on carbon, which is scheduled to reach $170 a ton by 2030, a low carbon fuel standard with the CCUS compliance pathways, even higher carbon values, And these policies, they're really, by putting a high value on carbon, it really provide the incentives for these projects. At the same time, the federal government has introduced significant investment support. For example, the investment tax credit, which provides up to $8.6 billion of funding out to 2030, rebating between 60 to 37.5% of the capital cost. And together, these projects work to really make the project economic case work out in many cases. Importantly, also, we have regulatory clarity in key jurisdictions around CCS frameworks and sequestration, and Alberta and Saskatchewan in particular are seen as global leading examples. We also have lots of storage. We've identified over 400 gigatons of onshore storage. And to put that in context, I'd mentioned 7.5 gigatons at the global level for net zero. So that's over 50 years at the global level. And for Canada's share, so for Canada's emissions to be addressed by CCS, it's somewhere from many hundreds to well over 1,000 years of storage. And then also on the infrastructure side, we already have some of the key infrastructure in place. And here the core idea is around CCS hubs, which many of you are familiar with, but it's the idea of sharing common, for example, CO2 transport injection infrastructure across multiple point source emissions, so that you're really getting economies of scale and driving down costs. And most of the world, that is still a theory, but it's already a reality here in Canada. We have the Alberta Carbon Trunk Line, which is the world's largest CO2 pipeline. It's already connected to 2 industrial facilities. At least 2 major ones are planning to connect to it, and more beyond. And what's really quite remarkable is that this project moved ahead essentially without social opposition. So the social license has been granted, and that's really quite remarkable, considering it's the world's largest CO2 pipeline, and definitely a different context from what we see south of the border and in Europe. And there are many more projects already planned and moving forward, more projects planned and moving forward. Now we can't get into the details. So that's the project strength that we highlight. So, next slide, please. But it's not just us saying these things, it's also some of the leading agencies and investors that are studying these things. And the International Energy Agency highlights that Canada is a global leader in CCS technologies, a number of projects and operations, so both the technologies and the projects there. JOGMEC, the Japan Oil Corporation, highlights that Alberta in particular is a leader with a well-developed business environment, a legal framework, and a carbon pricing system. And Jim Fitterling, the CEO of Dow Chemicals, has highlighted that access to third-party CO2 infrastructure is a key reason for locating his multi-billion-dollar net zero ethylene facility into Alberta. And what's great to see is that that investors are starting to take notice of these strengths. And as per our accounting, there are at least 10 what we call mega scale CCS projects that have recently been announced. So we define these as projects with capital budgets of above $1 billion. And they have all been announced since earlier in 2021, so less than 2 years. The combined estimated capital outlay to 2030 is around $25 billion. And the estimated sequestration capacity of these projects is around 30 million tons of CO2 per year, which will go a long way of getting Canada on track to its 2030 climate targets. And impressively, or I find impressively, is roughly equal in capacity to total CO2 sequestration capacity operating in the world today. So in just 18 months or so in Alberta and Saskatchewan, projects have been announced that equal the total global sequestration capacity in operation. And what I find exciting is that these projects, they're really across a variety of applications, but they include hub and support infrastructure, upstream and downstream oil and gas, chemicals, hydrogen production, power, fertilizer, and more. So it's much more than a one-trick pony. So that is on the project side, which is a lot of exciting things happening, but we still need a lot of technology innovation to make this a reality and to get the next step beyond that. And that is because many or even most of the CCUS technologies needed for net zero are not yet commercial. And the IEA highlights that 2/3 of the cumulative emission reductions come from technologies that are not yet commercial. And some of the key gaps that have been highlighted, and this is not an exhaustive list, but some of the key gaps include on the capture side, better solvents that have a lower energy penalty and are able to capture CO2 from challenging flue gases and lower concentration flue gases. Also, more competitive direct air capture, and $100 US a ton has been identified as a level where you can really scale this. On the sequestration side, we need technologies to assess the pore space more effectively, to both highlight and identify suitable storage sites, but also help with regulatory approval. We need to understand the dynamics of gigaton CO2 sequestration, which we have not done yet. And also we need to explore deep ocean injection viability. On the utilization side, we're going to be creating a lot of product, a lot of CO2, or for example, carbon black from methane pyrolysis. And we need to develop more novel processes to make use of these products and turn them into useful products and fuels. And one of the companies today in the panel can talk to that. And on the MMV side, we need to improve quantification to help build trust. And across all of these, we need to reduce cost to enable this to scale. So some major gaps that really need to be addressed. And we believe that Canada is really well situated to address these. Yeah, next slide, please. That's good. So Canada is really well positioned. We have a really high-performing CCUS innovation ecosystem. We have really world-leading and world-class academic research clusters, for example, at the University of Calgary, U of A, UBC, and University of Toronto, and more. We have at least 8 CCUS-specific testbed facilities that you can really think about as strategic R&D research infrastructure for CCUS. And some of the numbers bear this out. So we have 4th in global CCUS patents. We have 14% of overall CCUS patents. And we really have a disproportionate share of successful technology ventures. So we have at least 3 companies that have raised over $100 million to date, US. And they include Carbon Engineering, where we have Geoff Holmes from that will speak on the panel today, Swante, and Carbon Cure. And we have 4 X Prize winners or finalists, and we have a high-performing pipeline of new technology companies that are ready to address these technology challenges and be the next Carbon Cure, for example. Next slide. So while we have really strong innovation leadership, that doesn't guarantee commercial success. And Canada in particular has a history of having early innovation leadership, but then it's not able to capitalize that to commercial success. And some of the key things that we hear talking to startups in the clean tech space, but also in carbon tech space specifically, is a lack of capital in specific points in venture development. So startups find it more difficult to raise private capital than in the United States, for example. And public grants are available, but they're usually focused on the very early innovation stage. There's also a lack of market understanding by solution providers. There's often an excessive focus on domestic markets and not an awareness of the opportunities south of the border or internationally. There has been a solution fatigue within industry because they're overwhelmed by the number of solutions presented to them, and they don't know how to assess them effectively. There's a lack of ecosystem, or there has been a lack of ecosystem coordination. It's a complex and evolving system with different policies changing, grant opportunities changing, the R&D space changing, testbed infrastructure, customers, and that's really complicated for early stage startups to manage. And there's also been a lack of startup experience, including entrepreneurial experience and business training for the clean tech space. And there's a lack of connections within startups to sophisticated clean tech investors, to potential customers, or to potential strategic partners, and to public granting agencies. So those are some of the key gaps. So what are we doing to address these? And today I want to talk about 2 initiatives, and that is carbonNEXT and the Canadian CCUS Research and Technologies Network. And you go to the next slide. So carbonNEXT is Canada's CCUS Solutions Accelerator. So it's Canada's first CCUS-specific tech accelerator. And it's meant to streamline the journey of startups to commercialization. And as I mentioned, it's a partnership between Foresight and CMC. CMC, we bring CCUS-specific expertise. We bring really great testing infrastructure. We bring relationships with partners in industry and doing a lot of cutting-edge applied research along the CCUS value chain. And then Foresight brings the largest pipeline of emerging technology developers, comprehensive business training, and really an invaluable network of experienced executive mentors that can provide insights, business development insights, strategies, and importantly, these connections to potential investors and customers. So we're really playing to each other's strength. Next slide. So why carbonNEXT? Why us? What sets us apart? We're really trying to establish a unified presence of carbon tech innovation, supporting innovators from the very early stage innovation through to commercialization, piloting, commercialization, and then scale up and exporting to new markets. We do that, for example, by providing capacity building and training for innovators. That includes the Foresight business training, but also CCUS specific training, for example, exploring the latest policy developments and policy trends and market opportunities in export markets. We do that, for example, by building a network of investors and industrial partners to source CCUS solutions that meet their needs. And for example, we do this by running innovation challenges with industry partners on a specific industrial emission problem. And by running a challenge, there's really clear parameters on how to evaluate technologies. Industrial partners can do an apples-to-apples comparison and pick the technology that best fits their needs, help them commercialize, and then we can scale to other industrial applications. And then we support this through national expansion and, of course, export development through alignment and coordination, cooperation with export development agencies. And next slide. And the second initiative is the Canadian CCUS Research and Technology Network. And the issue here is that I'd mentioned we have this great testing infrastructure, but in the past, it's been difficult to navigate and access. So the solution is that most of these organizations that operate these companies have come together in a network that provides the one window access to connect the innovators to really the best facility in Canada for their specific technology needs, and that really help them to test, validate, and optimize the technology and take it to the next level. And go to the next slide. So that is an infographic we have shared of all the member organizations of the RT network, and that includes Innotech Alberta, which runs the Alberta Carbon Conversion Technology Center, NICAN CanMet Energy Ottawa, NICAN CanMet Energy Devon, the Advanced Materials Research Facility at the National Research Council. And at CMC, we have the Newell County facility where we do cutting edge sequestration and CO2 injection work and monitoring work, and the BC Research Facility where we can simulate different flue gases and test different technologies to address them. So that is, if you have more questions on this, we can point you to the right sources. But really the key goal of both the carbonNEXT and the RT network is to help drive a commercial inflection point that allows Canadian startups and clean tech solutions and carbon tech solutions to help our path to net zero in Canada and also globally. The next slide, please. And I've just thrown a lot of information at you, but I'm cautious of the time. We have a full agenda. So some of the key takeaways from this report is that I really do believe that this is a great opportunity for Canada. We have a chance to take an outsized share of the $1 trillion a year market. And to realize this, we should focus on 4 things that we identify. We need to really communicate our strength and intentions that we do have a lot to offer on this, and that we're serious about this, and we need to communicate this to international investors and project developers and innovators to come to Canada to take their CCUS solutions to the next level. We also need to collaborate across stakeholders, from industry to government to environmental groups and academia. And we need to collectively lean in to make this sector a success and make the most promising technology solutions a success. We need to ensure that we have a level playing field on project incentives. So I believe we have a really strong project policy environment now, but the United States in particular has upped the ante also with the Inflation Reduction Act. So we need to ensure we remain competitive, and that is something we will explore at a future webinar. And we need to focus on closing the technology gap by really focusing on piloting, demonstrating, commercializing, and scaling technologies. So Canadian technologies are at the forefront of enabling the net zero solution. And I believe if we do this, we're really positioned for success in taking an outsized share of one of the most lucrative markets in the low carbon transition. And now I threw a lot of information at you. Thank you for bearing with us and bearing with me. And now we have about 7 or 8 minutes for Q&A. So if anybody has any questions, please do here.
That was a great presentation, Maxi. We've had one question in the chat about direct funding associated with the carbonNEXT accelerator. I'm happy to take that question unless you would like to answer it.
No, please, Shannon, you're closer to this.
Yeah, so Pete, if I'm understanding your question correctly, carbonNEXT does not directly fund ventures, but what we do is provide you the tools and information on how to access that funding. For example, one of the ways we're supporting is we're running a grant course starting next week with a executive, Heather Herring, who is excellent at writing grants, and she's going to take a 2-day course with 7 different ventures that are under the carbonNEXT umbrella and give them really direct support on building those skills so that they'll be able to access non-dilutive funding themselves. But carbonNEXT does not directly provide funding to the ventures now.
That was the question. Thank you for answering, Shannon.
Great.
And also just to emphasize that the training provided through Foresight, and it is free. So all the training that we're providing is free of charge.
Yes, so if you're a carbonNEXT venture, we have many different pathways of support that we can help you, and it is free thanks to PrairiesCan and Scotiabank funding our program. We have another question. How can the ventures leverage the testing facilities?
So great question. The best is to get in touch with us, and we will put you in touch with our colleague Eric, who is coordinating the network, and he can assess what specific technology validation and testing infrastructure you need, and he can then help you point in the best direction. And Eric and Shannon, if you can put the email for the RT network into the chat, that would be great.
Yes, and we will also include it in the follow-up email for this event. So if you don't catch it in chat, you'll have a chance to see it there. Maxi, why do you believe that Canada has the best opportunity in this market? Is it our strength in oil and gas historically?
Yeah, that's a great question. I think that's part of it, but I think it's really a number of factors coming together. So I think it's our project strength, our oil and gas expertise and engineering know-how, deep expertise in geology, but it's also the policy environment. I think that's really changed things, right? Now we have a $170 carbon tax, billions of dollars of project funding, investment tax credits. So I think they work hand in hand. And then, of course, I think it all comes together with these, as I mentioned, these key ingredients for success with the technology, innovation, leadership, with great storage, which is great. We can help other countries even reduce their CO2 emissions through carbon dioxide removal, for example. And we're being really proactive on building out the infrastructure.
Great. And if you had one gap to look at, what do you think is the most critical gap for new tech startups coming into the space?
Oh, that's a great question. I think I mean, as I mentioned in the earlier slide, there's really lots of gaps, but just looking at the value chain and looking where most of the costs are, I do think it's on the capture side where you do techno-economic analysis. The capture costs are usually a big share, especially if there are sequestration opportunities close by. Other than that, I'm not answering the question because I'm going to pick more than one. I think the conversion and the utilization, especially the conversion, is a really critical part because there's lots of places that don't have great storage. And then, of course, carbon dioxide removal is critical, and it's been highlighted as by the IEA as I think one of the top 3 research barriers we need to address to get to net zero, global net zero emissions. So I apologize for really not answering that question.
What I'm hearing is that there's a lot of work to be done in the sector.
There's a lot of work to be done, yeah.
It's a very exciting sector. I think that's all the questions we've received. If anyone has more, feel free to put it in the chat and we can follow up with you. But we can move towards our next segment.
And do we have all the panelists here, Shannon?
Yes.
Awesome, great. Okay, great. The more exciting part of the event is our the great panel discussion, and the topic is success in Canadian CCUS, building new technology companies. And as mentioned, we are joined by 3 great panelists. We have Natalie Giglio from Carbon Upcycling Technologies, Brooke of Clean O2, and Geoff Holmes from Carbon Engineering. And these are really 3 of the most exciting carbon tech companies really anywhere in the world, and they're operating right here in Canada. And I'm going to ask each panelist to provide a quick introduction, describe the journey of their company from a novel idea to really being a world-renowned carbon tech company, and also share the missions and visions for the company. And I'll ask, I think, Natalie to go first. Natalie Giglio is a senior business associate with Carbon Upcycling Technologies. Specific focus is on advancing pilot projects, finding new customers, marketing, and external and government relations. So, Natalie, thank you for joining, and over to you.
Hey everyone, sorry if my voice is a little bit hoarse. I woke up with almost no voice, but we've been drinking lots of tea today. So yeah, like Maxie said, I work with a company called Carbon Upcycling Technologies that was founded and still operates in Calgary, Alberta. We were founded back in 2014. Our CEO, Apoorv Sinha, has a chemical engineering background, and he was working in oil and gas services. And one day the Alberta government put out a funding announcement to say, who can take carbon dioxide and turn it into something valuable. And he came up with the idea of taking CO2, combining with waste materials to create high performance additives that could be used to help decarbonize a whole bunch of different industries, from industrial plastics to cement and concrete to consumer goods to fertilizers. We really had this grandiose vision from the start of how can we take CO2 and turn it into materials to decarbonize various sectors. So fast forward a couple of years after 2014, we entered the carbonNEXT prize. So that was the prize that was funded in part by NRG and COSIA to support the development of technologies that were taking CO2 and turning it into valuable products. So Maxie mentioned the Innotech facility in Alberta, the Alberta Carbon Conversion Technology Center. That's where we operate. That's where XPRIZE, all the final competitors in the Calgary tract, we're operating out of during the competition. And during that time, we scaled our technology from a reactor that processed 3 tons of material per day to a reactor that produces 20 tons of material per day. So we did a massive scale up. It was a huge lift from our team to build this build one of the largest carbon utilization pilot facilities in Canada, and across the world we think it's one of the largest ones. It's hard to know, what everybody's doing, but from our current research, we think we're one of the largest utilization pilots, which is really neat to be a part of. That facility that we're at is quite unique. There's 5 different test bays. We get to be side by side of other companies utilizing CO2 in different ways, which has been a really cool ecosystem to scale up in. From the X Prize, we had primarily been grant funded. We had been scaling up through prize money. And what we ended up doing after we finished the X Prize is going to raise a commercial round to help support the scale up and sort of adoption to markets. We went and raised a seed round of $6 million US last year. And what that helped us do is build up more capacity in our team. We went from a team of 7 to now we're a team of almost 22 people now. So we've been rapidly growing, which is great. Many challenges that come with hiring when you're such a small, lean team to start with. But we've been really grateful for some of that funding that we've been initially been able to receive. And since then, we've been transitioning our technology from a batch system to a continuous system so that it better integrates with our cement and concrete partners. Because really, over the 8 or so years that we've been at this, we've really honed in on the cement and concrete market as our target audience for the enhanced CO2 additives that we produce. So we produce a cement replacement that can go into the cement at the manufacturing site or downstream at the ready mix or precast facilities. We just make a powder that has CO2 captured within it that can displace the carbon intensive ingredient, which is cement. So we essentially take our technology, install it at a cement manufacturing location, and bring in a local waste byproduct to capture CO2. So we think about local circular economies as part of the really one of the key value propositions that we bring to the market. So you don't have to rely on importing cement from overseas or importing other cement replacements from overseas. We want to be able to make those products right in Canada and produce low carbon cement and concrete right here, starting in Calgary. We have just started raising a Series A round to help us execute on some of the commercial contracts we've been able to secure in the last year, which is fantastic. We'll be building 3 more facilities, 2 in Canada and 1 in the UK, which we're really excited about. There'll be more announcements about those coming soon, but we're in the middle of that and hiring more folks and transitioning our technology from a pilot facility into commercial integrations, which is some of the challenges we're facing now. But that's a little bit about our story, some of the success we've had so far, and I'll pass it back to Maxi, and we'll continue with the rest of the panel. Thanks everyone for joining today.
Thanks, Natalie. Yeah, amazing story. That's really great. Next up, I'll ask Warren to speak. Yeah, so Warren is the Chief Technology Officer at Clean02, which is another Canadian carbon tech success story with a star-laced investor backing. And in this role as the Chief Technology Officer there, Warren develops the next iteration of the scrubbers, the CO2 scrubbers that help to address CO2 and capture CO2 from the building sector and turn this also to useful products. And Warren, I'll pass it over to you. Oh, you're on mute.
Oh, I love that. So of the moment you're on mute. Thank you very much, Maxi, and thanks, Natalie. Your voice was great. I could hear everything you said. So, yeah. So, thanks for including Clean02 in the success story. So we're on the track. We're on the right track. So that's good. I think we took a different approach, I guess, to tackling climate change. So climate change is a global, big, hairy problem. So 38 billion tons of carbon dioxide a year emitted to the atmosphere, which is daunting. It's a really sticky problem that seems insurmountable. But while we think big, we wanted to start small and do something that we can act now. So we are commercial now. We are selling our units. And what we do, we're addressing a specific component of emissions, which is the building heating sector. So most of the buildings in Canada, or Western Canada at least, are connected to the natural gas grid for heating. And it's hard to displace that fuel type once a building is constructed and is operating and occupied. It's hard to convert from natural gas to something else. And that's the same for lots of different technologies. Like, for example, I own and operate a car that runs on gasoline, and there are technologies right now I could take the gasoline motor out of my car and install a conversion kit and have an electric car. But that comes with a lot of headaches and a lot of know-how that you have to have. So I think in the same sense, building owners who own and operate their heating plants in their mechanical rooms, they could change to some other technology, but more likely they're going to continue owning and operating that same technology. And we have developed a system where you can keep your existing heating plant, your boilers, your domestic hot water heaters, continue paying your natural gas utility, and we come along on the exhaust side, and we bolt on a reactor that siphons off a portion of your flue gases. We process those gases. We grab CO2 molecules out of the flue gases and bind them into a carbonate, a solid carbonate, and then we send the rest of the gases back to the chimney. And we come and collect those carbonates at the end of the day, and we make stuff out of them. So right now we're making soaps and detergents and all sorts of cleaning products that are available commercially. You can go and get them at the Safeways and Sobeys and participate in climate change action yourself by washing your hands. And I was just doing a calculation, Maxie, while you were talking about cost per ton, and we actually pay the building owners $1.20 per kilogram of potassium carbonate that we are able to recover from their system until their system is paid off. So if you do the conversions, do all the math, we're actually paying the user of our system $3,760 per ton of carbon dioxide. So we're making money on carbon capture rather than it being a cost, which is kind of a unique situation in carbon capture. And we know we're not going to save the world with a bar of soap, but and we're probably going to have to convert to another technology to get into the megatons of carbon dioxide. But right now, it's awesome. We're commercial, we're doing the thing, and we're actually making money. And that's it. I want to pass it back to Maxie.
Great. Thank you, Brian. Yeah, fantastic story. It's really great. And then I'm going to pass it over to Geoff. Geoff from Carbon Engineering, I believe employee number 2 at Carbon Engineering, originally developed some of the early air contactors and has done a lot of publishing on direct air capture and techno-economic analysis and low carbon e-fuels, and is now in charge of government relations and external relations at Carbon Engineering. Geoff, over to you.
Yeah, thanks, Max, and thanks to everyone for including us in the event today, and great to hear from the others. So yeah, like Max said, I was actually working on direct air capture in an academic capacity here in Calgary when the group that I was a part of decided to spin out Carbon Engineering as an independent company. So I'm not sure I was number 2, but I was sort of one of the first batch who transitioned from academics to trying to make direct air capture work as a business. So maybe I'll cover a couple of the basics of the technology that we're trying to develop and deploy, and talk a little bit about the history of the company. So we chose at a very early point in time to work on a technology that we call direct air capture. And this involves engineering and building large machines and facilities to process atmospheric air and to absorb the CO2 and then to purify it and produce it in some kind of pure compressed format where it can either go into pipelines for sequestration in underground geology, or potentially get converted into products. You know, our favorite is liquid hydrocarbon fuels that have a low life cycle carbon intensity and can displace fuels with a high life cycle carbon intensity. So the whole premise for direct air capture is that, you know, we've got this 38 or 40 gigaton problem where we're transferring carbon from rock to air every year. And we believe that, you know, in many different places, we're going to be able to find ways to stop that transfer at the source. We're going to be able to stop a fossil fuel use and replace it with something else, or do carbon capture and storage on the point of fossil combustion. But then there's going to be other parts of our economy with the technologies and the know-how that we have today, it's going to be very hard to stop those emissions at source. So think about industries like aviation, where, you know, you're going to have a liquid fuel to energize airplanes, and you can't do onboard capture. So some amount of CO2 is necessarily going to come out of airplane engines. And where we can find renewable fuels like, say, biofuels or synthetics that can lower emissions, great. But if we can't do that whole job, then an alternative is to use a technology like direct air capture to absorb the CO2 back from the atmosphere afterwards and put it underground to compensate for the emission. And we think that by adding carbon removal provided by direct air capture with sequestration to the whole host of efficiency and at source mitigation technologies and practices that we have, that collectively we're going to be able to address climate change more quickly and more cheaply than if we don't have carbon removal in the toolkit. So carbon engineering was really founded with that mission to develop and then commercialize industrial scale direct air capture, and that remains our mission today. So we've been through a whole journey over the last decade plus of, you know, working in the laboratory to, you know, test out CO2 absorption by different chemicals and different means, working with providers of industrial equipment to understand how modules and equipment borrowed from industries like mineral and ore processing or water treatment or industrial cooling can actually be adapted and retailored to combine into facilities that can do direct air capture. And then several generations of piloting where, you know, in each successive step, we've taken more modules that will be required in an eventual commercial facility and knit them together at pilot scale. And we're up to the point now where, you know, we're in very late stages of a facility that costs, you know, tens of millions of dollars, and which we built in Squamish over the course of the COVID pandemic, which was an adventure in itself, and which will, you know, capture several tons of CO2 per day. Now, we don't do anything with that CO2 out in Squamish. This is still testing. So the whole thing is operated under what we call run, rebuild, run, where we're really just trying to give all the engineers and the scientists and the business people an ability to work with this equipment and innovate, get reliability up, get throughput up, get performance up, and try to get costs down. So it's really just a testing and development facility. And we use the knowledge that we gain from our two generations of pilots out on the West Coast to then feed into commercial scale engineering that we're now doing for commercial scale facilities that are targeted for Texas and Scotland and a few other locations. So these are slated to be very large facilities that will capture of order 1 million tons of CO2 per year each. We've just announced with partners 1.5 down in the States, plans to build 30 such units on the Texas Gulf Coast. So that's getting to, you know, a size that has never been seen before in the carbon removal or the DAC field, where once built out to full capacity, that whole fleet of units would capture something like 30 million tons of CO2 per year. That's great. We're ecstatic. Looking from the top down, it's still a drop in the ocean. That's actually 1/1000th of humanity's emissions, but it's still a good start. So we're kind of simultaneously working on those commercial projects now, and you know, further advancing the technology in Squamish. And I've got to say, you know, there's a whole generation of carbon capture and carbon removal technologies that are out there, and ready to go and ready to deploy. And one of the biggest remaining bottlenecks is actually the business model or the policy environment that sits around us. So look, water flows downhill and companies invest in projects that make money, to kind of fundamental laws of nature. And, you know, up until this point in time, despite some of the movement on carbon pricing and carbon taxes in certain jurisdictions, it's actually been really hard to make revenue, to make reliable revenues by doing CCS projects, and thereby, you know, defend to your shareholders that investments should go into these kind of efforts. So I think that's starting to change. We have some of the right ingredients here coming together here in Canada. We've got some good early ingredients in the United States, other ingredients in design in Europe, but frankly, we're not there. So we still need innovation both on the technology side and, in my opinion, also on the market and policy side. So look, I'll leave it there. Look forward to more in questions and discussion.
Yeah, great. Thank you, Geoff. And definitely agree on the policy side. And that is something we want to explore in our next webinar, is especially the project enabling environment for projects like US, between Canada and the United States, and why you're putting 30 million tons of projects into the South Coast, and when is the first one coming to Canada. Thank you so much. Before opening it to the questions to the audience, I do have one question. And in our report, we talk a lot about how to address, well, the key innovation gaps and how to address them in Canada. You all have represent great ventures on different parts of the CarbonTalks system. So can you just comment a little bit on what you think are the biggest gaps and what we can do to address those to strengthen the Canadian innovation ecosystem?
I guess I can comment first. So carbon upcycling, when we first entered the XPRIZE, started around TRL 6, which is right around the threshold for joining the Alberta Carbon Conversion Technology Center. And we're about a TRL 8, verging on TRL 9 once we do this next integration. And I think the gap that we're seeing is there's not enough government funding support to bring some of those TRL 9 projects that aren't mega projects. This is just like, you know, sort of the first commercial integration. There's not enough funding to support those. I mean, we're going after every piece of available funding right now. Oh, and then the reason we have to do that is because our commercial partners, they don't want to front all the money to do the first installation. They want the government to help subsidize that. So that's like one of the gaps that we're seeing, is that TRL 9 from pilot facility to integration at a commercial site. That's a big gap, and we see that gap in the US as well. A lot of the new funding out of the DOE and things like that are really, there's been several programs that are more focused on, you know, first of a kind commercial integrations rather than building pilot facilities, which is good. And I think we need to keep pushing for funding to support you know, bringing it to market, not just developing on the R&D side, because Canada does a good job funding R&D research and initial development of technologies and ideation and things like that. That's how we got our idea to where it is now, but now we're kind of facing this next hurdle.
Great, thanks Natalie. Yeah, that's definitely what we have found too. Warren, please, over to you.
Oh, sorry, were you going to say something, Maxi?
No, please, over to you.
Yeah, I'd like to echo what Natalie said. Like, when you're developing a technology that doesn't exist yet, like it takes time and money. So and people, human beings who have families and mortgages and like all the stuff that you need to be paid for, and to have a small team to achieve your goals takes some capital, which is hard to get. And Canada is kind of like, there's money available, but it often comes with caveats, like the grant is available if you can supply 50% of the money. And it's like, oh, well, great. It doesn't matter if I don't have any money, then it doesn't matter if it's $1,000 grant or a $10 million grant. Like, I just don't, I don't have the money. So it's hard to unlock the that second half of the money. And then the second thing is the hurdle that we faced most was regulatory. So we go into buildings, and the first few iterations of our machine, the local authorities having jurisdiction over the gas utilities and the gas code for buildings, just said, no, we've never seen this. You don't have a UL certification around carbon capture. So when you have your UL sticker for carbon capture, come back and we'll install this. Of course, there is no such thing. And it took us a long time to get that. So we had to do a lot of trailblazing in terms of getting the regulatory authorities comfortable with this technology, working with the UL laboratory, the Intertech, to develop a standard around carbon capture at a building scale. And like, it takes a lot of front end stuff that takes time. So keeping the doors open while that happens is tough. Anyway, that's my 2 cents.
Thanks, Warren. Geoff, any last thoughts on this quickly before moving to
I'll put another plug
in
for markets. So I think a common theme from our other 2 speakers, and something that we live through as well, is look, if you have some private investment to work with, there are a number of programs in Canada, both federally and provincially, that will write you grants to develop your technology. And until very recently, with some of the changes in the funding at the US Department of Energy, I would say we were actually better at that than the United States. I think they've now leapfrogged us and are putting some much bigger sums to work than we've done. But historically, we have had some good funding agencies in Canada here support the early stage innovation and development, with the caveat that you have to start with some private funding to prime the pump. Where we've really fallen short in Canada is kind of where Natalie said, where funding runs out when you get within that sort of one step of market and one step of commercial scale. I think, in fairness, I think the government of Canada has been trying to remedy that with some of their programs, like the Canada Growth Fund and the Strategic Innovation Fund. It doesn't always work perfectly and fill all niches, but I think they're trying to get there. The point I'd put out, though, is look, if we want to do carbon capture and carbon utilization on a commercial basis, then you're handling big flows of mass, right? And when you handle big flows of mass, you have big capital intensive facilities. You got a lot of equipment you have to pay for. And in virtually every industry, the business model is that you put a lot of upfront investment into that capital, and then you pay it back over multi-decades, right? So when somebody builds a power plant or a wastewater treatment facility, or you name it, the whole premise is that that's going to run for multiple decades to pay back the investors. And so grants can't cover that. Even if you could get the government to write you a check for 100% of your upfront investment, okay, fine. The facility still has to pay for its operating costs for the next 25 or 30 years. So you have to have some kind of recurring revenue out there. You have to have some kind of financial value that you're going to be able to access over the life of your project. And that has to come back to markets. So I think it's great to talk about grants and loans and all those things as companies start out and try to grow to scale, that's great. But we'll get a never-ending stream of highly innovative companies that then go bankrupt unless we have the markets in place to create a long-term demand for the product.
Yeah. And very important in this space where we have such great innovation leadership to capitalize on, potentially to work together, right? Great, thank you. I think we have time for maybe taking 2 questions from the audience. Shannon, if you have some questions from the audience.
Yeah, we had one question. Peter says, I have a hard time understanding the economics of DAC versus an LCA of CO2 required to build such technology. Can you comment on this? I assume life cycle analysis.
I'm not sure I'm understanding it perfectly, but I think if Peter is asking about how many emissions you incur while you're building the facility, the answer is sort of like a fraction of a year's worth. So quite often those aren't counted by regulators. But if you're looking at sort of like full academic style life cycle accounting, then yeah, you got to run the facility for the first several months just to pull back its construction emissions, and then you get into net negative territory after that.
And hopefully it will operate for many decades. Sorry, Natalie.
That's okay. One of the things that carbon upcycling has been looking at as we scale our technology is can we utilize like existing equipment and retrofit it to incorporate our technology? It's different on the DAC side of things. It's a totally different technology, but from like a utilization and integration perspective, like we're looking at retrofitting equipment, which helps on the overall LCA. So that's something that I think a lot of companies, not just ourselves, are thinking about as you try and reach large scale deployments.
And it'll get better over time, right?
Yeah.
We have to build our way into a virtuous cycle where, you know, a few decades hence, when you're using cement or steel or fiberglass or whatever materials to build infrastructure, those are coming from industries that have lowered their emissions, and therefore your emissions of, you know, initially building your facility are lower than they are today. So can build our way to success.
It's cool too, and like I mean, like a DAC facility that Carbon Engineering builds, I mean, requires quite a large amount of concrete. And if they can use concrete that we capture carbon into, right, like you can start to stack not only utilization technologies to help build the infrastructure of the other CCUS and other technologies, like that also creates a whole other dimension that we haven't even explored yet.
That's great. We have one more question. What program, relationship, or lesson would you say has been decisive in helping you survive and get to the stage you have achieved?
I think from our perspective, one of the decisions we made, mostly because we were capital constrained, but we could have hired some more people during our initial scale up, but we stayed lean in the initial years leading up to doing our first raise. And I think that served us really well. We were able to keep operating without, you know, pulling in other investors' capital. And I think that really painted a really interesting story when we first went to raise money, that investors were quite surprised by, and then they were excited to help us grow and reach a larger market valuation. So that would have been one thing from us.
I think we did the same thing, actually, Natalie. And when we went to the investors, they were surprised at how far we had come with the resources that we had. So they were surprised at how little money we were asking for. And to be honest, like that's good for us too. Like we are lean, and it kind of keeps us moving the ball forward. So now that we're in a better position, we're able to be more reasonable about what the value of the company is to further, like we're approaching a Series A as well. So what we have proven that we can do is more beneficial going forward.
Great. Thank you, Warren. We have a few more questions, but we're at the top of the hour, and I'm conscious that people want to drop off and need to drop off. So there's some other questions. We'll try and work to address those to you in email and in follow-up. In the meantime, Shannon, do you want to go back to this to next slides again? Just a quick plug on the great events that are coming up for carbonNEXT. We have our next CarbonTalks scheduled for December 14th, where we are going to explore the project enabling an environment between the US Inflation Reduction Act and the Canadian CCUS policy. So stay tuned for that. We also have the next carbonNEXT cohort that's going to be onboarding soon, and it's going to be, the sessions are going to be running between February and April 2023. And also we have the Foresight, the demo day and the Foresight 50 coming up at the end of November. And you can stay in touch on all these great things by signing up to our newsletter, which I believe that Shannon has just put a link into the document. So
that's our survey. But
oh, sorry, the survey. So there's a post-event survey. If you could fill that out, that would be fantastic, and helps us improve our webinar series for you, for our audience and members. And yes, if you want to stay in touch and up to date on what's happening, please sign up to our newsletter, which I believe Shannon will put a link in a moment. And next, we have the panelists have graciously agreed to volunteer another half an hour of their time. And we're going to be breaking into breakout rooms, and you can choose what panelist you want to have a discussion with. And we'll give instructions on that in a moment. But I do want to leave you with one question to stimulate the discussion. And that's now in our research paper, we identified the great project, CCUS project pipeline. And we want to explore what can we do to better coordinate the opportunities between this $25 billion project pipeline and to give more opportunities for Canadian CCUS innovators. So just a question to maybe help stimulate the discussions a little bit in the breakout rooms. And now I'll pass it to Shannon for Zoom instruction, because I'm not a Zoom expert. Can you repeat the opening question? Sorry, it is what can we do to better coordinate the opportunities from CCS projects, the development pipeline, and opportunities to get more opportunities for CCS projects and developers, tech startups. So I'll put the question in the chat. I think we are at the end of our event. I don't have anything else to share. Please do sign up for our newsletter to stay in touch with all the great things that we're doing. And if you could fill out this survey, that would be fantastic and helps us improve our webinars in the future. And many thanks for everybody to showing up today, participating in the event. And of course, a huge thank you to the three panelists too, Warren, Natalie, and Geoff, for a really great discussion. And looking forward to seeing many of you in the near future. And with that, everybody have a good day, and people in Calgary, hopefully you stay warm.